Symmetry. Yay, symmetry. So I've got some pictures here of things that are symmetric. You guys know what symmetric means. But we're going to look at 3 different kinds of symmetry. We're going to look at line symmetry, rotational symmetry, and point symmetry. Yay. Okay. This is line symmetry. Look at that dog. So this dog is symmetric. Here's a line of symmetry right there. So a line symmetry, that occurs when a figure can be mapped onto itself by a reflection over a line. And we call that line the line of symmetry. So like this point on this here, you fold over on that line, it's going to match the kind of a corresponding point on the other side. It's a reflection. So that's what I just said. Fold along with the 2 halves coincide. You don't have to be symmetric, so some things are not symmetric at all. You can have 1 line of symmetry. You can have more than 1 line of symmetry, depending on the picture. Alrighty, so let's look at some examples of line symmetry. So in nature, so the butterfly is an example of having a line of symmetry there. They map up. I don't know what this thing is. It's a creepy crawly, but whatever it is, it's symmetric. I had an expert in the other class who said, yeah, those are little spines of poison, and I'm like, okay. So I don't know. Somebody knows what this is. So if you get stung here, if there's a matching side, you can get stung on the other side. The alphabet. So I'm looking at some uppercase letters. This is called vertical symmetry, because it's upside up and down, right? This is called horizontal. So if I fold an A, it's symmetric. If I fold that B. Here's some words. This word has vertical symmetry, mom. Fold it in half. They're going to line up one against the other. The word ease, right? Go that way. You have some symmetry in a word as well. Polygons have symmetry, or they can have symmetry. So a square has some symmetry, and it's got lots of different lines of symmetry. We'll be looking at the polygons and the alphabet a little bit more closely. So starting with the alphabet, you may want to put these on your paper, because what I want you to do is I want you to think about how many of these uppercase letters, capital letters, show vertical line symmetry. So and again, do this on your own. We'll compare notes in a moment. For example, I'll give you a hint. A does, because there's a vertical line in it folds. So that's one of them. So go ahead and go through there and see, and you can just write these on your paper. You don't need to look up in mine. Write them on your papers, because I think it's hard to look up, look down, look up, look down. So try that. And if you finish that one, go to B. How many of these letters show horizontal line symmetry and going this way? Can you have those symmetries? So try A and B. See if you can come up with some answers there. Do you think you have an answer for A? You can raise your hand. Do you think you know? Christian, how would you get? 10 of them?
Nope.
How would you get there? 10? How would you get, Madison? 11?
Yeah.
What'd you get?
11.
11. What'd you get? 12. Oh boy.
Oh,
So why is it different? Well, let's see. I can show you what I got. I got these letters. Now it may depend. Like if you
Oh,
draw
11.
your
I got it.
U like this, you probably didn't count it, right? Because then it's not symmetric. Or maybe you make a Y like this. You probably didn't count it. So I can see why maybe we're getting different answers if perhaps we draw them a little differently. But I kind of looked at what I saw up here, and to me it looked like these were the ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I got 11. So if the reason you got 10 or whatever is because you weren't counting some of these, I guess you're right. Did anybody do the horizontals? You think you know how many horizontals? How did you get to that? 8. How did you get? 9. Oh. 10. 9. Oh. All right, well, let's see. Now, these are the ones I chose. So 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. But maybe if you make your B looking like this, then it doesn't have that symmetry. So if you're doing stuff like that, that could be part of the reason why we're different. Yes? N? This one? Well, if I do this, do I get the exact same thing if I fold along that line? So this point is going to come up, right? So this one, N, is not symmetric, or it doesn't have horizontal line symmetry. Yeah? Did anybody say, how about S?
No.
Yeah. It doesn't. Like, you got to really think about that. So when this gets folded up, this part's up here, right? So it's not going to have it. So be really careful when you're thinking about that. How about both? I want one letter, right? Each letter that has both horizontal and vertical. How many did you get there? 3. What'd you get? 4. Jerry, how many did you get?
Four.
Four. Well, we're basically looking at the intersection of these two sets, right? So H, you can go that way, you can also go this way. I, O, and X, and they appear in both lists, right? The ones that appear in both lists.
I don't know, I just forgot to transfer it.
Forgot one, okay. So now we're going to just play with the words a little bit. So mom, this word has line symmetry. It actually has vertical line symmetry. If I fold along there, right? Wow does as well. These are vertical line symmetry. You can have words with horizontal line symmetry, like this word, right? Now you think of other words with either vertical or horizontal symmetry. That means all the letters, you fold the word in half, you get a match. If I have some words they can think of. Yes? Cookie. Right, you set that line through there. Thank you. What else? Again, these are the hints, right? You got the letters right there. Yes, sir. Okay. Okay? Just the okay? Okay. Okay for okay. But if I make it like this though, it doesn't work anymore. Right? Book. Book.
Chick.
Chick. Okay, that works, yes.
Hoax.
Hoax. Oh, what about this one? I don't know if the A works. Almost. I don't know. Almost. I don't think the A works, but we're close, very close. I was trying to think of the longest word I could find. I'm thinking about it. You have another one?
Yeah.
The only one I'm worried about is the A's and the N, but the H's work. Now if I go this way, do the N's line up? The A's and the H's do, but then the N's don't line up. It's close though. Ooh, that's close. Hammer. We can make the name Hammer. We're good. Yes, Susie. What? Okie dokie. Okay. I don't know how to spell it.
It's two different words. There's one word dash and then.
Is that how you spell it?
O-K-E-Y dash.
I don't know if there was an official way to spell this.
There's no official way to spell super compound.
Well, that I do. Not that I can spell it. Okie dokie. Wow. The Y doesn't work, right? The Y doesn't work. Can you spell it with the E's? Oh, my goodness sakes. Really? Apparently I'm misspelling it. It's O-K. Well, if you spell it this way, I agree.
Look it up.
Not right now. This guy is like, you're wrong. This is the longest one I could think of, which, Okeechobee? This is, what? It's a city in Florida. There's a lake Okeechobee.
Oh, yeah.
Yeah. There may be more. I don't know. That's the longest one I can think of. But you get the idea. You get the idea. Okay. Now this little imagery with line symmetry, they didn't copy it 100% on your paper there, especially B, but how many lines of symmetry do they have? So basically, like, this is a sea star, right? I can't call it a starfish. It's a sea star. It's not a fish. So there's one, right? There is another one. There is another one. So how many lines of symmetry does this thing have? It looks like it has 5 lines of symmetry. Now this flower, they did not copy well on your paper here, so we should look up a little bit. Okay, so I think there's one here, and there's one here, and there's one here, and there's one here. Now if I really think about it, if I put one through here, right? So I think I've got 4 more of them. I think this one actually has 8. And it's really hard to see it on your paper, but I think this one has 8 lines of symmetry. Because in the petal, I can like fold in the middle of a petal, it should line up. Well, I can't because if I go like here, then it's not symmetric anymore. So I think 8 is it. I think 8 is it. Now, the next one is a hexagon. And let's see, it looks like I've got some vertical symmetry here, but I also have some horizontal. So this one looks like it has 2 lines. 2 lines of symmetry. Yeah. Now this is also a hexagon. This one is a regular hexagon. Oh, so let's see, I can do 1, 2, 3, but I can also go through the vertices here. 1, 2, 3. So this regular hexagon has 6 lines of symmetry. This is a scalene triangle. Lines of symmetry. I don't see any, right? So I put those 2 here so we can maybe draw a generalization. And again, it's a little bit inductive, but let's see if we can kind of convince ourselves. If you have a regular n-gon, how many lines of symmetry will there be? How many?
And the amount of lines.
N, right?
Wait,
Yes.
doesn't the letter Q have like a diagonal line?
Well, I'm only looking at vertical horizontal. If we're looking for diagonal, that's like a whole nother thing. Somebody was trying to tell me L did. I was like, only if you make L where these 2 things are equal. But that's why I'm only dealing with this way because, I'm not doing that. Okay, back to this. Regular n-gon has n lines of symmetry. The word regular is important, right? Because this hexagon did not have 6 of them. How many lines of symmetry does an n-gon with no equal sides have? That's like this one. Yes? You row. If you don't have any equal sides. If it's scalene, you will not have any lines of symmetry. So, that's right. That's right. Okay. And that's my lines of symmetry. And you basically just don't look for it. And these 2 rules help you. All right, what else? Rotational symmetry. Rotation, so returning. Returning. So an object has rotational symmetry if there's a center point around which the object is turned. There's a certain number of degrees. And when you turn it those number of degrees, you get kind of the same object. It looks the same. So my little example here is this pinwheel thing. So when I turn this thing 45 degrees, does it look the same? No, but when I turn it 90, does it look just the same thing? So this one, if you rotate it 90 degrees, you get the same figure. Or how about if I take it and I rotate 180 degrees? Do I get the same thing? Yeah. When else will I have it? At 270. So that's saying if you were to take this and turn it 3/4 of the way around. So there's kind of 2 things we think about. The order of the symmetry indicates the number of turns you can do to get the same thing. So I can go 1, 2, 3, 4. This has an order of 4. Now an order of 1 is basically something that there's no way to turn it around except the whole 360 degrees. That's the only rotational symmetry you have. So there's basically no amount of degrees. Because I'm not going to count 360. So when I talk about the degree positions, so for this one, it's the same if I rotate it 90 degrees. It's the same if I rotate it 180 degrees. And it's the same if I rotate it 270 degrees. Now it is the same if I rotate it 360, but that is the same thing that I'm starting with. So I don't want to count that again. So at 0, we always know 0 works. What are the other ones? 90, 180, 270. So let's look at some other examples here. So I'm on the back here. Everybody's on the back? Yeah. Okay. So see this thing here? So the order of this, how many times do I turn? And I can see the same figure, and then I'm back at the start. Well, I'm looking for a number. Order 4. 1, 2, 3, 4, right? Now the rotations are what? 90. Well, what else can I do? 180. 270. The next time I go, I'll be at 360, which is back at 0, so I don't need to count that way. This thing here, I think that's a hospital center. I don't know what that is. This is in order 2. How come, Christian?
Because it's at 180 degrees, it's the same as if you turn it back to what it was.
So what's the rotation here? It's 180. This is a roundabout symbol, and I guess we're in England now because it has us driving backwards here. So this is a roundabout sign. What's the order? Wait, somebody else. Who's like, what? What are you talking about? What's the order of this thing? you getting these numbers? So if I kind of turn it, this one will kind of take its place, right? And then how do you figure out the degree? So, Miles, what would the degrees of rotation be? Or what else? Where is this coming from? Where are these numbers coming from? I divide 360 by the order. 360 over 3 is 120. And then I keep adding 120 until I get back to the 360 mark. If I were to add 120 again, I'd be back at 360, which is the same as the 0 position. Now I got a little horsey sign. It says horses there. Order of this thing. Huh? What? One? Why is that? The only way to get back here is if I go 360 all the way around. I'm not even going to put any rotation degrees here because 0 is 360. Like I can't really get anything other than the same position here. Yeah.
With a blank sign, you just circle what it has.
Oh, a circle. What are you going to do with that? What's the order of a circle? Mine's just a, right? I guess we have an infinite order on that. So circles are kind of hard because I don't know, we can turn in an infinite number of degrees, right? We're going to get the same thing. So that makes my head hurt. But if you have like an international interdiction symbol, you know what that thing is, this, right? That does have symmetry. We can figure that out. But when it gets to be just a plain circle, that's too hard. Okay. What else? Oh, so now we're going to look at geometric figures with the rotational symmetry. What? Yeah, it was just no rotation. We just kind of leave a blank there for the other one. So let's see if we have geometric figures. It's the image of itself under rotation. It's the same thing. This is basically saying what we just did. So I've got this regular polygon. This one's a hexagon. And this is a regular hexagon. So what's the order of rotation for this thing? Jerry? 6, right? 1, 2, 3, 4, right? And what about the angles? Oh, forgot that. You're right. So how do I find the angles here? Like this one would be what? 60, 120, 180, right? We can just keep adding the 60. So if it's an n-gon, you're basically going to do a 360 over n, and that's what you keep adding. So the hexagon has degrees of rotation of 6. So I divide 360 by 6 to get 60. Keep adding the 60. 120 plus 60. 180 plus 60. 240 plus 60. If I add 60 to this one, I'm back to my 360. I don't need to do that one. So order, rotational symmetry, and then finding the angles of rotation. It is very inductive, yes. All right, last little symmetry we're looking at, point symmetry. Point symmetry. Every point has a matching point the same distance from a central point. What? We did this sort of a little bit when we did reflections, a point reflection. So we said like you have that point, and then you like say, okay, let's see, however long that is, you go the same, and that's where its matching point is. However long that is, you go the same. However long that is, you go the same. And it turns it upside down. This was 180 degrees. We did talk about that with a point reflection. It's the same thing. It's the same thing. It's 180 degree rotational symmetry, but the easiest way to know if you have point symmetry is if it looks the same upside down. Or I really should say in opposite directions, left or right if it's the same, or up and down the same. I always look upside down. So how do we do that? So I'm looking at this thing. This is that pinwheel we had before. So now I gotta turn myself upside down. I'm turning myself upside down. Oh, is it the same upside down? Is it?
Yeah.
Yes. So this has point symmetry. This thing is a playing card. Believe it or not, does anybody know what playing cards are? I've had people like, what's that? Right, you know, there's 52 cards and there's 13 cards in a suit, there's 4 suits. Joker. Well, joking. So does it have point symmetry? Turn yourself upside down. Yes, it does. Notice some. Not all playing cards show point symmetry. Some words do, some words don't. Now for this one, we're going to be a little bit little lax here. Is this show any sort of rotational symmetry? I basically want 180 degree rotational symmetry because that's point symmetry. does the word mom show point symmetry? What's mom upside down? Wow, and you better believe that. Mom and wow, yes, but it does not show point symmetry. What about the word mo? Turn it upside down, and you see mo again. And that swims.
Yes.
How cool is that? Yes, it does. So, I think what we'll do is when you come back, we'll do these retries. Before we go, there's a question, yes? Which one? Which one is not point symmetry? Mom does not. Yeah, that's a no. All righty. When you come back, do these. Yeah, those first few done, you can check your answers. Got those guys. Yeah, I'm just turning the page here. I'm very proud of Dee. Very, very proud of Dee. What? It is now. Yes, mom is now a word. You know what it means. Do we have questions? Everybody's grinning. Rank order 2, same thing upside down, 180 degrees. Order 3, because you can rotate this 120 degrees, 240 degrees before you get back to that final rotation. This one was a hubcap with an order 5. So 360 divided by 5, that's where the 72 came from. Keep adding 72, and you get those different angles. The point symmetry, come on. Yeah, you're not going to get it now, no swims on month. If you turn this upside down, it says the same thing. The whole sign has point symmetry. Math does not have point symmetry, but noon does. Anybody turning their paper upside down to tell? You know, just turn it up, yes, turn it upside down. How come this card does not have point symmetry, but this card does? Why is that, Christian?
Card on one, because the heart in the middle, that's facing up. So,
Right, this thing does not have point symmetry, this heart. But a diamond does. And that's really all there is kind of to this. Are there questions? Have you get stuck on anything? You did not. Awesome. Then my hand. That was good.